Hi guys, welcome back to my mathematics tutorial. And in my today's lecture, I will be looking at differential equations. So particularly, I'll be looking at variable separable, or one of the methods of solving a first order, first degree differential equations. So we said in previous videos, when you have a differential equations and it's possible to separate the, the different variables in, you know, within the differential equations on both sides of the equation. Like you have an equation wherein you have x and y. So if it is possible that you rewrite the differential equation such that the x expressions are on one side of the equation and the y expressions are on the other side of the equation, then it's possible to apply variable separable method by just integrating both sides of the differential equation and finding your general solution. So we want to apply that method in this problem to find the equation of the curve that is represented by this differential equation and is passing through the point 1, 1. So in order to find the equation of that curve, we must first be able to solve this differential equation using variable separable and find the value of the arbitrary constant c using these points. Then we replace the value of arbitrary constant c in the solution of the differential equation. So your final answer now will be the equation of the curve. So let's get started. We have y equals y minus yx dx plus. So let's just move on. We should not rewrite again. So we already know that y and y, we can factor out y. So we'll be left with 1 minus x dx. And then this we can factor out x. We'll be left with 1 plus y dy equals to 0. So I will maintain 1 plus y dy and then send this across the equal sign. So it will be negative y times 1 minus x dx. So because this is dx, so everything here must be in x, so y has to leave. Likewise, because this is y, everything must be in y, so the x should also go. So y cancel y, x cancel x. We have 1 plus y over y dy equals negative 1 minus x all over x dx. So the variables now have been separated. We take the integral on both sides to find the general solution. So we have the integral of 1 over y dy plus the integral of y over y dy equals the integral of 1 over x dx plus the integral of x over x dx. That is, we multiply this by this and this. So this is just the ln. So the first one is just the ln of y. So y divided by y is just 1. The integral of 1 is just y. And then this is also the ln of x. And then x divided by x is just 1. The integral of 1 is just x plus some arbitrary constant c. So we first want to solve for this arbitrary constant c. And then we replace it in the general solution now, thereby finding the equation of the curve. So we say at x is equals to 1 and y is equals to 1 because the point 1, 1 is x, this is y. So what do we have? We have the ln of this is 1 plus 1 minus the ln of 1 plus 1 plus arbitrary constant c. So what is it? So we send this 1 across. Let's get some. This 1 can cancel this 1, right? If we send it across, it will be negative, in fact. Now, the ln of 1 is equal to 0. And then the ln of 1 is also equal to 0. So 0 is never positive or negative. It's just 0. So C is equal to 0. So therefore, the equation of a curve is just equal to the ln of y plus y equals to negative ln of x plus x. So if you like, you want to simplify it further, you can further simplify it, but you can just leave it as it is, no problem with it. So there's the equation of the curve that is represented by this differential equation, and it's passing through the point 1, 1. So thanks ever so much for watching. See you in our next lecture. Thank you.